since it's a cloud as well, I can scale it out. I can say, well, what if I want this database to be running over 3 units? In other words, I want 3 pieces, three servers providing that database. I can just ask for that, and abracadabra, magically, that integration happens. But this is still a bit painful because I've had to essentially do something that everybody knows they're going to do, right? If you're going to have a content management system, it's going to be a database. It's going to have a database. What if in fact all of the work of figuring out what needs to be connected to what if that could be provided in advance? So what if I could just go and say, look, I want to find something that does a whole bunch of things in one hit that might look like this. But what have I done? Magically, I've said, well, somebody else has created a predefined set of integrations of complex parts, and I want to reuse that whole, what we call bundle, in one hit. And so this tooling now is allowing us to work with startups who have complex pieces of software. Complex software today is many pieces of software across many machines. It's letting us take them into big enterprises, telcos, large integration shops, SIs. It's letting us help them show that their software does interesting things much, much faster. Instead of taking 6 weeks, 8 weeks, 12 weeks to do an integration and a proof of concept, they can do that in an afternoon. So I think this is a game changer because it drives value on both sides of the equation. This is all free software, this is all open source. Nothing proprietary here. We're interested in this because the faster we can have people adopt cloud, the more they're going to use something like Ubuntu, which is a platform that works very well on the cloud. But what's fascinating for me about it is that I see how entrepreneurs, startups, and how IT guys light up when they see this, and they realize that that is now 15, 20, 50 servers within minutes up and running in production, ready to take data, ready to analyze data, ready to generate results. And when they realize that this picture can be modified live in real time, if they want to try a different management system, they just drag it in, integrate it, and immediately are able to see if it's working. So a profound game changer in terms of the way that back-end infrastructure works. What about that third arena, the third area where I think this game-changing stuff happening? Well, on the side, I have this amateur interest in space, space cadet in every sense, and you know, since the 1960s, we've had the same basic parts getting us into space, right? We've had liquid rocket engines, and the problem with two liquids is that they mix very easily, and if they have if they're explosives, then mixing them makes for very, very big explosions, very impressive and very expensive explosions on the launch pad. So all of your liquid rockets, they generate a lot of thrust. They can be controlled very efficiently because you can turn up the rocket engine and turn it down, but they tend to explode. And when they do, it's a very violent, very dangerous, very expensive kind of explosion. The other kind of rocket engine we've had are solid rockets. Tragedy with solid rockets, in this case a real tragedy, is that you can't turn them off. Turning off a solid rocket is like trying to sort of stop a match head from burning once you've struck the match, right? There's nothing you can do. That match head will burn. Only after the match head's completely burnt out can you perhaps blow out the match. The problem with socket engines, with the solid rocket boosters, essentially is that the fuels again are pre-mixed. And so once you light it, it will, you know, from ignition, it will keep burning until it's out. You can only use it once, you can only burn the whole thing at once, and that's it. Great if you have a very heavy object that you want to get into orbit, not very good if you have things that you want to use in a subtle kind of way. So what's the game changer? Well, two interesting new developments in hybrid approaches to rocketry. The first is hybrid solid liquid. So you've seen a lot of commentary about space tourism and the new generation of vehicles that will provide access, suborbital access to space? Well, they're all using this new approach to rocketry. So what are they doing? They have solid fuel, but only one half of the fuels. The other half is a liquid or a gas. And so that provides a very interesting combination. They get all the properties of solid fuel. They get a very high thrust ratio, but they also get many of the benefits of liquid fuels because they can turn their rocket on and off. So that's why you'll see a lot of new things like the land speed record. The current challenges to the land speed record, they want to use this kind of rocket. All the suborbital access guys are using this kind of rocket. A much safer, much simpler, much more controllable way, potentially, to get us to space. There's another interesting concept, though, which is this one, which is to say, well, one of the challenges with rocket engines is that you have to carry both. You're carrying your oxidizer, essentially the thing that oxygen, and the thing that burns. You're carrying them both from the ground all the way up. What's silly about that is that most of your energy goes into getting out to the atmosphere, and the atmosphere is full of oxidizer, right? It's full of oxygen. So some very smart people are now working on being able to combine rocket and jet engines. And this is a project in which I have a very distant interest, but which is led by some really brilliant engineers in the UK and now increasingly in partnership with companies in Germany and France to create hybrid jet and rocket engines that will essentially be able to fly in the atmosphere like planes and then switch into rocket mode out of the atmosphere so that you can fly to the top of the atmosphere in what looks like an aeroplane, essentially take off from a runway, get to the top of the atmosphere, then become a rocket and get to Australia in just 2 hours. So again, a game changer. At the end of the day, it's very interesting, when we look back, these profound game changers, they look obvious. But at the time, they look anything but. And that's what I love about this field, right? That all around us we have assumptions about what's possible. And those assumptions are breaking down every day. Thank you very much. I hope that was interesting. And
any questions? Because we've got about 5 minutes left. Any questions from the audience? Anyone want to ask anything? There's a lot to digest here. The notion of the cloud for you. The cloud is everything to you right now, it sounds like.
The cloud is absolutely central to all the work that we're doing with industrial, large-scale computing. And so, anytime you think of a data center or servers today, that is now shifting into a cloud mentality. Hardware is being designed around cloud infrastructure. Software is being re-engineered to work well in those scale-out kind of environments. A way of thinking that was pioneered by Google, but is now becoming standard for everything.
I didn't hear you really say anything though about security and privacy, and obviously everyone's talking about that right now. What's your opinion about guaranteeing the maximum amount of security if so much is taking place now in the cloud?
I think security is fundamentally a question of practice. And I think experts would agree that there is nothing stopping you from being secure and adopting cloud technologies. You just have to have good practice in what you do and where you do it. You can build a cloud in a highly secure environment, keep information there which you segregate from everything else. You can use public cloud environments if your information is something that you can take a certain amount of, you have certain tolerance for risk. So security is really about practice. Privacy ultimately is about regulation. We will have no privacy in the absence of regulation. There are too many incentives for both us and the people that make stuff for us, right, to violate our own privacy. So we love using free software, right? And I don't mean open source, I mean software that's free, right? If there's a great saying that says that if you're not paying for the product, you are the product. What that really says is that your privacy, the violation of your privacy, is the business model.
Okay. If you're not paying.
Right, but we love it, right? We love all those free apps that you can download and use. And so fundamentally, in the absence of regulation, whether that regulation is focused on transparency and making it clear when your privacy is being violated, or simply enforcement and saying that it's not legal to violate people's privacy in certain ways, in the absence of that, we have no real expectation. I have no real expectation of good privacy for the average person.
Okay, you don't expect that. We've got a tweet here: spaceflight and open source software. How come? I guess that meaning, how do those two go together for you?
What's great about open source is that you can have confidence that it's being used in a wide variety of applications, and there's a lot of visibility, and you can repurpose it to do whatever you want. I have a good friend who is into rocketry, and all of the control systems that he uses are open source. At a more industrial level, a lot of the systems that control next generation rocketry are all being built on open source. So open source is at the heart of the vast majority of supercomputers today. It's at the vast majority of mobile phones, the vast majority of embedded devices. I don't think there's any reason to think that open source wouldn't be central to space technology in one form or another. I was quite glad that the capsule that we flew, the Russian capsule, the control panel on that was an 8-bit processor, which we had to program in Octal. It was from the 1970s, but that actually gave me a sort of warm, fuzzy feeling.
Why you felt safe?
It was well debugged. By the time we flew it, it was 30 years old, and they probably found most of the bugs in it.
That's right. Talk to us a little bit about your phone project.
So there's not much point in doing something just like what other people have done. That's not interesting. There's usually a market for a SORAN. We're about the third or fourth company in the market. So what's interesting for me about what we're doing is this converged story, because it's profoundly new. The hardware that I showed you there was from Asus. They're trying to make it work with Android, and it's very challenging because Android wasn't designed or built with this idea of being all of those kinds of personal computing. We had the great luxury of starting late, so we were able to sort of think about that very deeply before we got going. And I think as people get more excited about the idea of having a personal computing device, which at any instant can be a phone, can be a tablet, can be a TV, can be driving wearable computing, can be a PC, then they'll appreciate the gem that we have in the heart of the Ubuntu Mobile story. We have our first two manufacturers, so I was very excited at MWC to announce. One great European company, BQ, real company that really understands how to insert itself, put the right device in the right hands. And then similarly in China, a company called Meishu, sharp elbows, guerrilla operator, knows how to go into a crowded market and differentiate. So I think that's a great start for us, and I look forward to.
Who is going to be the user? Who will want your phone?
If you look at the way we segment the market, two groups. The first group that's extremely important for us is people who don't really want to be that fussed about the phone. They want something that's clean and beautiful, easy to use, and does all the basic things really well. That's something we can control. We can deliver something for that audience because we know the apps that they care about, we know the functionality they care about, and we can test the usability of Ubuntu against Android and iOS and Windows and other options. And there we do pretty well. We have a lot of bugs to fix, issues to address, but we will deliver a phone that's much more usable than Android for that audience. And then the other audience is the developer audience. These are guys who want something amazing. And the devices that we think are possible to create when you have convergence are extraordinary, right? You can develop once. From that phone, you can push your software to the cloud. You can target all these different form factors, phone, tablet, PC, TV. You can target them all. We will add wearables to the story. And for developers, that's extremely exciting, right? The idea that they can be productive in an environment that they know, and then reach all of these different kinds of audiences or form factors.
And imagine if we're not talking to an audience that knows everything about the technology, if we're talking to a broad audience, they were to say, okay, here's my iPhone. Tell me what's wrong with my iPhone. Why should I get rid of this and go to Mr. Shuttleworth's baby?
So an iPhone user is not our target audience because there's a level of emotional connection to the Apple ecosystem, which I think they've earned. I think Apple has earned that emotional connection that people have to iOS and the Apple ecosystem. to other platforms. And so the question is, can we create something that people will have in motion? And to do that, I think, so if you look at the non-iPhone audience, I think you say, all right, well, today you're carrying around, look at you, 2 brains, 3 if you count your own, right? You're carrying that around. Do you have a laptop with you?
I have a laptop.
Look at that. What if you could have just one? You've only paid for that brain once. And the others are just pieces of glass.
Yeah, let me challenge you on that. I would like to just have one gadget. I think everybody would, and I wish it could be this. But this is easy to carry. But visually, it's too small. I like to have this when I'm sitting up here on stage. So when are you going to give me a hologram that beams up and gives me a big screen? That's what we want, right?
Not a hologram, but you are seeing projectors. So you can carry a projector around here. So we're seeing all sorts of innovation around this idea. We launched a Kickstarter crowdfunding program to try to make the first device that could be a PC. And it failed spectacularly, but also succeeded spectacularly. It broke the record for the amount raised in a month, and it broke the record for the amount that missed its goal by in a month. So 2 records for the price of it. But what was interesting, 20,000 people came out and said, wow, that's very interesting. We want to have that device. And since that Kickstarter, we've seen a number of manufacturers come out and say, we thought that was super interesting and told us a lot about what people are interested in. So we're starting to make devices that can live up to that dream, to that vision. So yes, you don't want to do your email all day long on a phone screen. It's great to be able to do one email, quick reply, yes, no, on a phone screen.
Right.
It's a great story about executives. Executives love doing email on the phone because their emails consist of yes, no, and maybe, right? That's easy on a phone. If you actually have to do work, not going to happen, right? Then you'll carry something more. But what do you really need? You need the brain, and then you need access to the right form factor, right? And look around you. How many screens are there here? If it was really cheap to provide those screens, would you start to get comfortable that on every plane the screens will just be there? In every hotel, the screens will just be there. If you have to, you can reach in and grab your glass. How much lighter would that tablet be if it was just the battery and the display, and that's it? And the answer is it would be much lighter, and much cheaper, much more disposable, much more reusable. So it's not that you don't want to be able to type or use a mouse or use a bigger screen or a smaller screen. That's not what we're saying. What we're saying is it's unnecessary for you to have to keep all of those devices in sync with each other, because you could have just one brain.
What's your phone going to cost?
So ours will come out in the mid-high range, so $200 to $400 devices. We're going for the high end because we want people who are looking for a very sharp, beautiful experience, and because our ambition is to be selling the future PC, the future personal computing engine, essentially, and to support our partners in doing that.
And this is very disruptive. I mean, do you have Android and iOS scared? Are they shaking in their boots? Are they done that? Or do you think they're taking note of what you're doing?
I certainly think they are, and I think we have a healthy line of communication, certainly in the Android community, because it's relatively open. And the Google guys are relatively open in their thinking too. And I think at some level everybody knows that platforms serve a purpose, and then that purpose, is served in a better way by something else. And Android has really served its purpose for sure. But perhaps it's time for something new. If you really look at the heart of Google's business models, I don't think they totally depend on Android, right? They depend on having great services. And so we're an open platform to integrate services into. And of course it's very attractive to everybody who's not Google, but it doesn't mean it's not attractive to Google.
Anyone in the audience before we wrap up? We got one right here, this gentleman right here. Microphone. Liebe Studentin, ganz hinten, habt ihr ein Mikrofon? Ja, sure. Das ist auch.
Hello. So you talked about the Ubuntu Edge. Thank you very much and giving us the idea, saying I will have one device and this device will be used as telephone, will be used as tablet and also as PC. And I suppose when I go to work or I need more power, then I connect it to the cloud, and also the cloud or whatever it can be, just a USB stick that's backup of this hardware. Is that our main idea?
Yes, very much so.
Thank you very much. And
got a lot here now. What advice would you give to an industry leader like Mark Zuckerberg? Do you think he wants advice from anybody?
No, it doesn't want advice from me. And the worst kind of advice is advice. But I do think that the great privilege and burden of people thrust into that kind of position is the obligation to think 10 years ahead, which is extremely challenging. It's, between us, a guy monkey like me can look 2-3 years ahead, and we can say, well, that screen can be bigger, it can be lighter, it can have more displays, maybe it's got more dimensions to it. What's really hard is to look 10 years ahead, and I think it's also really, really fun. So I think that the real challenge is always to be able to maintain enough mental capacity surgeons today to look 10 years ahead. And that's why, for me, I'm quite happy to be wrong for 6 or 7 years about the convergent story, right? But the fact that we're already seeing things that tease at the edges of that suggests to me that it's not even 10 years away.
Final question. Space travel. When do you foresee going into orbit, let's say going around the Earth one time, being affordable for the masses? Or let's say, can you imagine a time, give me a timeline, when it would cost, let's say, $1,000 to go around the Earth once in orbit?
You need quite a few laws of physics to be stood on their head before we can do it for $1,000. Either that or need some severe deflection. Just to put orbit into perspective, the space tourist flights that are being advertised today, which will happen in the next couple of years for sure, and they'll be fun and they'll be deadly.
But it's still prohibitively expensive.
Some orbital flights, $200,000,
yeah.
$250,000.
Okay.
Those require about 1/60th of the energy of an orbital launch. In other words, to get you from the kind of parabola, 3 minutes, 5 minutes in weightlessness, to get you from that to an orbit is a factor of 60 in energy. But of course, it can't be a factor of 60 in weight. Or if it is, you're burning up a giant piece of equipment. To get to $1,000, we have to reroute our understanding of gravity. I don't think there's economically a way that we can do it.
In this century, you're saying?
Well, you never know with science, right? There's a really interesting experiment happening right now, not far from us in CERN, where they are looking at antimatter. You all know antimatter, right? We've had antimatter we've known about seeing antimatter for 100 years. We don't know if antimatter falls down or falls up. Think about it, that's fantastic. If this was antimatter, and I let it go, first bad idea for Europe, but if that was antimatter and I let it go, the question is, would it fall up or would it fall down? And we don't know. We absolutely don't know. There's nothing in our laws of physics that says it has to be one way or the other. And we've never actually looked, right? This is quite hard. So that is, for me, the most interesting bit of physics being done right now. Because if antimatter falls up, well then, maybe we're starting to get the first sign of being able to harness gravity. And if we can reshape gravity, well then rockets will be a very smelly, old-fashioned way of getting into space.
And also, it means planes wouldn't have to necessarily crash or disappear.
Every aspect of transport
in Malaysia, for
would be
example.
transformed. So that's why.
Okay.
That's why. There's a profound and potentially game-changing.
Yeah, we're going to close with that. I don't think I've ever been in a high-tech show before and ended a discussion talking about antimatter. So, Mr. Shuttleworth, thank you for bringing something new to our discussion today. Thank you very much. Thank you. That's going to wrap up our program for today. We will see you tomorrow. We've got a lot of very exciting panel discussions tomorrow, so we're looking forward to seeing you tomorrow morning. Bye-bye.